Good afternoon, ladies and gentlemen. My name is Paul Fanning, Editorial Director of MA Business. The webinar, How to Design BIM Compliant Products, will begin in 2 minutes. Good afternoon, ladies and gentlemen. My name is Paul Fanning. I'm Editorial Director of MA Business and Editor of Eureka. And I'd like to thank you for joining us today for this webinar on how to design BIM-compliant products, which is brought to you today by Eureka Magazine and Building Products Magazine in partnership with Autodesk. If you have a question you would like to ask during the presentation, please simply click the Ask a Question button and type it in. Hopefully, we will be able to ask your question during the Q&A section. But if your question isn't answered today, please rest assured that all questions will be passed on to Autodesk and you will receive an answer in due course. Equally, should you experience any technical difficulties, please click on the Ask a Technical Question button and detail your problem. Alternatively, try the View Alternative Stream button. But first, let's examine the background to today's discussion. Building Information Modeling, or BIM, has been a game-changing technology for the construction industry, and by extension for anyone supplying to it. Fundamentally, the concept behind BIM is to build better buildings. By use of digital tools, it ensures that all parties involved in a project have access to the requisite information needed to achieve a successful end result. This removes the pitfalls associated with traditional methods and enables the development over time of an information model of the entire building in real time. By embedding key product and asset data in 3D models, BIM enables the effective management of information through a project lifecycle, from earliest concept through to operation. Its advantages are clear, since it enables more intelligent decision-making about construction methodology, safer working arrangements, greater energy efficiency, and a critical focus on the whole life performance of facilities or assets. For these reasons, BIM has seen widespread adoption throughout the construction industry, supported by a range of global initiatives to facilitate its understanding and use. This has been encouraged by governments, which have introduced a number of initiatives designed to incentivize uptake of the technology. With this in mind, the UK government has mandated that all centrally procured public sector projects require the implementation of BIM. Meanwhile, from October 2016, it has been necessary for all centrally funded departments to have the capacity to electronically validate BIM information delivered from their supply chain. In addition, they had to be making progressively more use of supply chain data for key business activities. In effect, then, this has served to make BIM capability mandatory for anyone supplying products into any centrally funded public sector project. This has obviously brought with it a number of problems. Design engineers are accustomed to producing CAD models of products and components, but these are not what building designers and architects want. They require lightweight geometry, enriched with all the required product data. By contrast, 3D mechanical CAD models contain far too much non-relevant data for design and construction clients. They can also be extremely large and unwieldy files, and are often not compatible with the design software used by architects and construction companies. One solution currently used is to redraw products using a different design tool. However, this creates considerable duplication of effort, additional cost, and risk of error. Alternatively, some manufacturers pay a third party to redraw and manage their entire product library. However, this also adds risk to the process, is costly, and leaves them dangerously reliant on an outside agency. What is needed, therefore, is a process that allows the manufacturer to define and generate simplified BIM-compliant data by converting detailed mechanical designs into lightweight BIM objects for use in construction projects. How that can be achieved is what we are here today to discuss. And in order to do that, I'd like to hand over now to Dave Wilkinson, Technical Sales Specialist UK for Autodesk. Dave.
Thank you, Paul. Thanks for the introduction, and welcome to everyone today on the webinar. So, what we're going to look at today is, broadly speaking, some options or some ways to address that BIM for manufacturing scenario, if you like. And if we first look at what we're looking at there, so excuse me. Within building products, equipment and fabrication, if you like, that encompasses a vast array of products, as you can see on the slide. Manufacturers, anybody in the manufacturing space that needs to supply into the architectural industry, any of these products that you can see in front of you, need to do so from a manufacturing point of view and be able to design, fully document and communicate that design to someone who has to then make it. Now, in the manufacturing world or engineering world, that's great, and that's a normal thing that we would do. But when it comes to transferring those into the architectural world, most of that mechanical design and information isn't required for usage within the architectural world or from a BIM point of view. So what we find is that most mechanical design applications and design models, if you like, are far too big, far too complex for architects to deal with. And that really, as you can see there, a list of typical challenges that manufacturers have, if you like. Things like the level of detail, what information's embedded in those design files and such like, and how we communicate that. Okay. Now that's all great, but we can break that down into probably three typical areas, if you like. And as you can see there, simplifying the layers of detail or that level of detail is one of the key things. And the reason for that is that if we have fully manufactured data and we communicate that to the architect, first of all, we're transferring our intellectual property maybe on the design. And secondly, we're translating or we're communicating far more data than is required. And quite often that can become unwieldy for an architect to consume in the architectural space. Other things, design intelligence, or if we have a design of something and things need to connect to it, then being able to identify those in an intelligent way. And thirdly, having the correct property information. So you as a manufacturing supplier, your details around what you've supplied, what that product is, maybe it's maybe additional data around maintenance plans. And it could be anything really. And that's not specifically a defined set of things from a BIM perspective, or what's required for BIM, it can be specified in the BIM specification on a particular project. But those are three key points that are relevant for anybody in the manufacturing world that wants to prepare their data for consumption or being consumed by the architectural world and conforming to a BIM standard, if you like. Now, as an example of that, we have here is, what we will have when it updates, is an example of the levels of detail. Okay, so in the first instance, at level 0, we just have a simple footprint or representation of a chair in this case. And then as we step through those different levels of detail, depends upon what is actually required specifically for the project, and that would typically be specified in the specification for the project from the architect. From a modelling perspective or from a manufacturing perspective, you can see that level of detail differs greatly from level 0 up to level 3, where we've maybe not got a fully detailed model from a manufacturing perspective, but we do have the full detail on the extremities of the model. So in this case with the chair, we can see some colour, potentially some texture, and you know, the true form and shape of the chair itself. Again, that's a key thing within that cycle, if you like, as we translate that data into the architectural world. Having the right level of detail that's fit for purpose is very important. So from a manufacturing point of view, you as a manufacturer supplying into architects from a BIM perspective, what level of detail a customer is expecting is obviously a key one. Another point is what property information needs to be included. So classification data such as Uniclass, Omniclass, etc. Product data templates, COBie information. IFC classification. Now, a lot of these are buzzwords, and it's not something I'm going to get into today because they can vary depending on what the project is, but they're all things to be aware of, and I'll show you some points as we go through the data and the data set in a moment where some of that's actually being specified. More importantly, how easy it is to specify that from the design tools. And then how will your information be used downstream? So is it going to be operate inside of a building? Is it reference only? And again, if you think about that chair example I've just shown you, the G0 or the level 0 of detail is just a reference, as a footprint, whereas the other extreme was level 3 or going beyond that could be more detailed and such like. So there isn't when we say BIM, there isn't a one-size-fits-all from that perspective. Again, it's very much related to the project, and then that project specification will drive what you typically deliver from a manufacturing perspective. Okay. Now, again, in the time we've got today, I'm just going to cover really three areas or three common workflows that we see typically within manufacturing for BIM. The first, catalogue parts or components, and then configurable products or systems, and architect supplied or fit out, if you like. And if we look at maybe some different products as examples, and just highlight what those products are. So here I have a range of 5 different things, if you like, workflow, not specifically that we have, but workflows that we can address quite quickly and easily within software. So the 3 that we're going to look at today is immediately usable content, BIM on demand, where we're looking at configurations or product systems, and then project-specific data, where we're actually referencing to architectural information and being able to design to fit to that. Okay. There are obviously additional ones as well, so adding additional intelligent ground light fittings, for an example, or using that data downstream for maintenance and installation. But for today, we're going to look at, first of all, that first workflow, where we're using immediately usable content. And one of the key things here is that if we break that down, we're looking at the design tool, as you like, in our case, Autodesk Inventor. Inventor's a great 3D design tool, but it also allows us to have some quite well integrated links into the architectural world with Revit. So the simple workflow that you see on the screen there is the first instance being the design tool with Autodesk Inventor, then having tool sets within there to be able to simplify the model and maybe parameterize that to change the design automatically within the design tool. So we're building the right model to export out as a BIM component. And then from there, we've got a couple of different ways we can go. If it's a range of products with different sizes, we can then start addressing BIM on demand. Or if it's just a fixed size, we can then export that directly out as a Revit file, or to conform to the BIM generic standard, if you like, for the file format, which is IFC. We can also go out to that IFC format. One key component to realise here before we get into actually looking at this working is at the design stage, Inventor's capable of doing this simplification and export, but we're also able to read in additional data formats as well. So in talking to customers, people out there that are having to do this, it's not necessarily that they're using our design tool to start with. But the benefit here is that we can still translate that information from other vendors into Inventor and then translate that through into Revit or BIM on demand solutions. So I'm going to just move forward here and just give you a scenario with a workflow that we're actually going to look at. So the scenario is like an air conditioning unit, and the air conditioning unit, as you can see now, has been designed as a full manufacturing model. We then need to simplify that model for a number of reasons, and I'll talk through that in a moment, and then we need to utilize that inside of the architectural world, so in this case inside of Revit. So let's have a look at that actually working. And I'll just let that slide come up and you can see excuse me, Inventor actually working. So what I've got here is my full manufacturing model at the moment, okay? And what I'm simply going through now, you can see here that it's made up of different components and such like, but I'm now going through and using some of the simplification tools here to basically give me basic rectangles for the geometry that was included. So what was originally sheet metal components are now being generated as just solid blocks of material. So straight away I'm removing the IP or the intellectual property that I have. But more than that, I'm also removing the overhead and the geometry complexity that means that the model's more heavyweight. You can see there that it's basically solid inside. The important bit though is the outside, in so much as that the dimensions are still physically correct and such like, and I've still got the connection points as you can see me adding here. So from an extremities point of view, the model is still the same. I'm now placing my orientations and configuring the model to be consumed with inside of Revit. I'm now doing my classification, then adding metadata into the file so that maybe my company information about where this needs to be mounted and such like, so that all of that information is embedded in the actual file. And once that's done, I can export that out as a Revit file in this case. I'm now in Revit and I'm now going to consume that. So I've simply loaded it in as a Revit file. I've now simply positioned that as you would normally do with any component that you download inside of Revit. But additional to that, I'm now able to do some piping with MEP inside of the Revit tool. But because I've specified those location or connection points inside of Inventor or the design tool, I can very quickly and easily connect to those and start doing my pipe routing. More than that, if I make a design change inside of Inventor, in this case I've added some additional components on there, I can reread that file in and actually update it inside of Revit. So I'm not having to re-import the updated data if required. Okay, and inside of Revit, all that metadata and information that I've populated as part of my BIM process is still there and available, consumed. So that's just one example of immediately using content. We're going to look at a couple more in a moment, but that just gives some idea of, first of all, bringing the data or configuring the data within inside of the design tool, simplifying it to remove IP, and then transferring over to the architect or over to the architectural world with Revit. So the second data, or the second scenario rather, with the data set that we're going to look at is project-specific workflow. So in this case, we're working a slightly different way around. In the first instance, we have reference data coming from Revit. We then need to do our design work, but we're doing our design work to reference that Revit data. And then we're going to do the same thing where we simplify the design and send it back to Revit. So it's more of a round-trip process. But the important point here is that we're actually getting the architectural information to reference the design fit to in the first instance. So that allows us to ensure that the things, providing the building is actually manufactured correctly to the Revit model, then obviously our design data is manufactured or designed to the Revit model as well. So what you see here is me accessing the Revit data within inside of Inventor. Now I'm not bringing the whole project in, I'm just choosing a subset of that componentry, and that's this particular part of the building here. Now I've got my staircase already designed and built, but I've got some additional design intelligence in there that allows me to manipulate that design quite quickly and easily. You'll see that in a moment. But right now, what I'm doing is I'm constraining my staircase into where it should fit, but I can immediately see that it won't work correctly. The size needs changing because it's too big. So using some of the additional design automation tools within Inventor called iLogic, I'm able to quickly and easily change that staircase and now see from a design perspective that it's fit for purpose. I could obviously add more design intent in there and do further modifications on the design. That's good enough. All I need to do now is simplify that design again, put in some classification, add some metadata, again, all building on the BIM story, if you like, and preparing this model for export as a BIM model. Once that's done, using the same tools that you saw before, I can then export that out as either an IFC or a Revit file. And once I've done that, it can be then consumed within the Revit model. We'll see there that'll export out, and then once done, we'll see the Revit design on the architectural building, and then I'm able to import that file or that same file into the building, locate it where it needs to locate, as you can see now, and then that's me done from an architectural point of view. Again, the point is, because I've been through the process of embedding my metadata, also simplifying the geometry, all of that information is embedded in that file. So from Revit, I can go and expose that if I needed to. But most importantly here, I can see that inside of Revit now, my staircase is located correctly. It's in the right location that I want it, and it's also fit for purpose. That's because it's been designed around the Revit model to start with as that round trip process. Excuse me. So the third workflow or scenario that we're going to look at is where we have a family of products. So in this case, we're going to look at like a tap for a sink and kitchen unit, something like that. This has got different sizes, different options available. So in the first instance, from a design and author point of view, from a manufacturing model, I need to do the design work to ensure that everything works. So the mechanism works, the seals are the correct size, the fitment's correct, maybe the finish, all the standard stuff that you would do as a product designer inside of Inventor. I can also add more intelligence into that so that if I have a number of different sizes, I'm using that design automation functionality we have in Inventor to allow us to easily change the design rather than having to go in and manually change it for each size that I want each time that's required. So that's just part of the design process, and that's what we do as a standard really inside of Inventor for product design. The difference comes when we want to translate that or transpose that over to the architectural world as a BIM model. Now, as maybe a size A, size B and size C, To export those out to Revit, because of the complexity of the geometry and the manufacturing information, the only real option I have is to create 3 different models for that and then send them to Revit. So that's one way, and we can do that just as you saw with the air conditioning unit, or the staircase for that matter. However, if we want to be a bit more intelligent about that, the option that we've got is to build that design intent within inside of Inventor, have the different range of options available built as the design so that we can quickly and easily change that design using iLogic, and then we're able to upload that to our configuration portal called Configurator 360. It's very, very easy to do with a few button clicks. What we have inside of Inventor gets uploaded to a web portal that's secure, that you can expose on your own website. And then from there, that configuration and choosing of options that you saw with the staircase inside of Inventor, we can do exactly the same through the web portal, but just using a web browser. And then from there, we're able to download an IFC or a Revit file to utilize inside of the architectural world. Okay, so it's a different way of looking at things, but it allows us to still have the manufacturing complexity, like product family range, configured within the design tool, but also expose it to a consumer or somebody who wants to use our product in the architectural world. And for example, here the tap variation, well, the tap has 63 different variations. Okay, product colours, sizes and such like. So that's the level of complexity we have right now with this particular design. So let's have a look at that actually working. So that plays through. Here we have the design inside of Inventor. Okay, so we've got multiple components inside of this design. I've got that design automation tool inside of there as well with iLogic. So this is part of the design process. But you can see here I'm very quickly and easily able to change the different configurations of that product. You saw there that I've got different levels of detail in here again as part of the design process, where I've got a solid version with nothing inside and I've got the full manufacturing model. That's part of the design process. What I'm doing now is the same process that you've seen before with me actually configuring this for BIM output. So I've got the levels of detail already configured. I'm entering the metadata in there, and now I'm uploading that to my Configurator 360 portal. That just allows me, excuse me, to upload that full data set. That can include drawings, manufacturing specifications if required, and allows me to place that on my web portal. Now I'm looking at that, but this time through a web browser. I've got almost the same level of function. Well, I've got the same level of functionality, but it almost looks the same from a form perspective, where I'm able to change the sizes, the colours and such like, and get a representation of how that will fit against the basin or where its fitment is. But I'm doing this through a web browser. Okay? So this would be the person who wants to consume the data. So the architect looking at your product range, they can choose what they want, and then once they've chosen that, they can actually download that as a Revit compatible file, be it a Revit file or an IFC file if it's going to another architectural product other than Revit. Once that's done, it's the same process as you saw with the staircase or with the air conditioning unit, where I bring that in, I load the family, I bring it in, and then just place it on the basin in this case. And then that's part of my architectural design. Once again, the prime point here is that it's got all the detail embedded inside of it from a BIM perspective, because we've added that manufacturing content, okay, with metadata. So manufacturer or whatever's required from the BIM specification on the project, and that's all embedded, and it will live with that file as it goes through to the project. Anybody looking at this BIM model, maybe in years to come, actually focusing down onto the tap, would then be able to expose that property information and actually see who, you know, your name as the supplier would be in there, and what other relevant information that you've input as part of that BIM specification. Okay, and that as really as an overview of the BIM process, if you like, are 3 of the typical workflows that we commonly see within this manufacturing, or building products and manufacturing for BIM is typically what we see within the industry. There are different ways of approaching it, different workflows, but that's typically what we would see on a day-to-day basis with those three examples that I've given. Using Inventor as a starting point, primarily as the design tool, and then processing through into the architectural world. So that's for the technical content. That's about me. And with that, I'm going to hand back to Paul.
Thank you very much, Dave. We have a couple of questions here. One is relating to file sizes. Somebody has asked what the size of the file that was exported from Inventor was, that was shown and then brought into Revit.
Okay, so that's a really good question. One of the key things with the whole BIM process is to reduce the file size. That's kind of one of the things that you saw through all three videos, really, was manufacturing level of detail is far in excess of what's required for the architectural world. If you consider that, I don't know, a housing block with 500 apartments in it or something like that, and if we added that tap with all the nuts, bolts, washers, seals and everything, it wouldn't work because there'd just be far too much data. So, in a direct answer to the question, I'm not entirely sure. If you looked at it from a factor point of view, it could be reduced something like tenfold, something like that. It really depends on the data and the level of complexity that's in there. The whole purpose of it, or the BIM process, or the BIM simplification tools we have in Inventor, is to reduce the geometry information so that it's as small as it can be. And again, that's kind of a question, first of all, based on the BIM specification against the project, as I showed with the level of details, whether it's a really block example, or block model that is required for the project, or whether it's more of a full detail model for the project, where you've got the outside surfaces and shape accurate, but inside there's no content. So it really does depend on the model that you've got and what the project specifies.
On a related note, I think we've got another question which is asking basically what kind of time does it take for the conversion process from Inventor to Revit?
Okay, so again, another really good question, and kind of apologies for not giving maybe direct answers to this, but really depends on the level of data. The videos that you saw in the presentation there were slightly speeded up just to condense them into 2-minute slots for the presentation, but not excessively so. So all the components that you saw there would have converted with under 1 minute on just a standard generic laptop using Inventor and Revit. So not massively so. If you've got huge model data, then rather than just taking the entire thing and simplifying it, you might take that in stages, but you kind of take that approach if the model was really large.
And another one, for people not using Inventor, are there any issues with the conversion process?
For people not using Inventor?
Yeah.
So I can't speak for other vendors, but as I've mentioned in the presentation, we've have a number of customers that are not primarily using our design tool for designing their products, but because of the efficiency that we have with the BIM simplification tool and link to Revit, they will take their data and load that inside of Inventor and then use Inventor to simplify the model, populate the BIM information and then export through Revit.
That seems to be all we have time for today.
Okay.
Any further questions that people may have, obviously, as I said at the beginning, will go to Autodesk. Should you wish to review or share today's webinar, it will be hosted on our websites eurekamagazine.co.uk, buildingproducts.co.uk, and autodesk.co.uk. In the meantime, it just remains for me to say thank you to Dave Wilkinson for his presentation today, and to thank you all for taking part in this event. Thank you very much.
Okay, thank you.